Okay.
Yeah, we are live now. So, hello everyone, good evening. So, today was a very interesting day with amazing sessions, and we have another amazing session on Web3 and blockchain, which will be taken by Shaurya. He is a JavaScript developer and Web3 and blockchain advocate, and a very good knowledge on blockchain. So, he will be briefing us about a very hot topic that is blockchain and Web3. So, now over to you now, Shaurya.
Yeah, thank you, Siddharth.
Shaurya,
Thank
can
you
you
for
hear me?
such a nice intro. Yeah, yeah. Am I audible?
Yeah, you're audible. Please move on.
Yeah, yeah. Thank you, Siddharth, for such a nice intro. Good evening, everyone. My name is Saurem. I am a front-end JavaScript developer, as well as Web3 and blockchain advocate. And today, we would be having an insight on how beginners can get started with Web3 and blockchain, and what actually is blockchain. Why is there so much hype about blockchain and Web3? So, let me share my screen. Okay, I guess my screen is visible right now.
Yeah, it's visible.
So, okay, Web 3.0 and blockchain. These two terms are used interchangeably most of the times. Whether you visit any technical community or tech Twitter, the most hot and trending topic nowadays is Web3 and blockchain. But why is it so trending, and what it is actually? The most common tagline used with Web3 and blockchain is the future of internet, revolution. But how? Let's dive deeper into it. So, before getting into Web3 and blockchain, we need to know how it all started, how internet was born, and how we got to how it got to the its present state. So, internet gained its wide popularity uh, up around about 1994, when search engines like Google were just introduced, and the prices of internet packs started decreasing. So, the first phase of internet was called Web 1, and it started in 1994 to 2004. But there came a company in 2004 whose name was Facebook, and it completely revolutionized the web ecosystem then. It got introduced in 2004, and it is still now. And then comes Web 3.0, which is still in transitioning stage. We will be diving deeper into each of these states of internet right now. Yeah. So, what Web 1 did is, Web 1 was primarily focused on broadcasting data, means you cannot interact with the data that was being shown on your screen. You could just read it. There was some person who was putting the data on the over the network, and what you could do was to just see it. The data was just being broadcast. You couldn't add anything. Also, it had a very narrow implementation, such as suppose if you need information to be known to everybody, then only you could use the web 1 mechanism to show it to everyone. Almost zero public participation was there. As I stated earlier, you couldn't do anything with internet. You could just go into your browser and see what the other people had put in, not the common man. Okay. Then comes the web 2.0 with the revolutionary ideas. It focused on creating public network and engaging more and more people to networks. What it introduced was communities, creativity, the World Wide Web, Wikipedia, social networking, interaction, privacy, network blogs. All of these came after 2004, when Web 2.0 was introduced. And Facebook is considered as pioneer in transforming the technologies of Web 2.0. And after that, content consumers became content creator. Let me brief you about this points somewhat more. What we normally did in Web 1 was, we used to just read data. But now over Facebook, we can post our own data. We can do posts, we can create polls, we can do anything we want. Almost everything we want, we can do it on Facebook. So now people who were consuming the content, they started making content, they started developing content. Many people actually got livelihood out of it. So this was Web 2.0. And now we are transitioning towards Web 3.0, which is even better. So if Web 2.0 was so good that it made content creators the content consumers the content creators, what was the need to move to Web 3.0? There must be some issues. So here are a few issues I have listed. The first one being security. The data breach in many multinational companies has become a news of every other day. Every other day, we have a news that the data of several users compromised at this multinational enterprise, privacy compromised, this that device has been hacked. But the most important factor which triggered the developers of Web3 was the monopoly. Here, a very early disclaimer that we are not targeting any enterprise here, but here you can see some companies listed in this illustration: Wikipedia, Skype, Facebook, Twitter, YouTube. In today's market, we can say that these companies have actually established a monopoly over the internet. By the monopoly, I mean it has become very difficult for any new startup in the same field to gain market. Not because uh, not because people are not preferring them, but due to the monopoly established by a few tech giants such as Facebook. Any social networking company emerges in the market, Facebook goes and buys it. We have witnessed it with many. The freedom of speech and expression, the censorship in various countries, such as mainly the countries ruled by the communist parties, or more specifically China, where no social networking site is allowed. Whatever you chat with your friends, the government can actually censor it. The government can actually know what you had in lunch, what you are going to have in your dinner, and they can even influence it. You cannot say a word against the government. You cannot say a word against the authority, even if you are 100% right. The freedom of speech and expression was curbed so effectively in Web 2.0 that it triggered the developers of Web 3.0 to make it secure for all those who truly believe in freedom of speech and expression. Now, coming to the next main point, frauds. I'm sure you must have received a call from a fake agent of any bank that, sir, this I am talking from this branch, I am the branch manager, you have won a lottery, you need to transfer this the and you will gain you will get a 1 crore or 2 crore, or even I got a call for 20 crores to get in my bank, although I had to transfer 5 lakhs for it. These frauds these frauds won't be possible if the blockchain and Web3 gets introduced. If the blockchain and Web3 gets accepted widely in the environment, we will see to it how it won't be possible. But the mechanisms put forward by Satoshi Nakamoto, the founder of Bitcoin, have actually put a restriction on who can change the state of the block. We will get deeper into it right away. And the concentration of power. The one who holds the social media controls the internet. That's why almost every political party has an IT wing running in their society, isn't it? Aren't we familiar with it? So let's move on to the next slide. Yeah. So how Web3 is really gonna help us? The first point being peer to peer. Almost 50% of the secret lies in this word, peer to peer. That means if me and my host Dinky are going to talk anything, Nobody else in the world can know what we talked with until and unless we want them to know. It is not possible. It is impossible. It is virtually impossible. Why? We will get into it later. I know I am saying we will get into it later, but believe me, I will surprise you. Open. It is open to all. Every Web 3.0 project which is being built, almost 90% of them are open source. They have been built by the communities of developers uh, who truly believe in web being free. A great example for this can be the Linux distributions. The way Linux distributions revolutionized the operating system market, operating system world. I'm sure Web 3.0 is going to revolutionize the internet. Permissionless. You don't really need to ask anyone what you want to put from your side. You don't really need to ask your government, hello, Mr. Prime Minister, can I put this on my social media? Will there be any punishments? You can you can say truth without any fear, without compromising about anything. So enough talk. Let's get straight into what is actually blockchain and why is everybody talking about it. So in next 15 to 20 minutes we would be covering these points. Why is everyone talking about blockchain and why you should learn it? How it is going to make a difference in the present system. This is the main point I would be going to cover. Why it is called blockchain? How did the word came and who created it? Let's get into the first question, who created it? So frankly speaking, the blockchain technology is not so new, although it is much younger than the existing technologies. But the blockchain was first introduced in about 2008 by an anonymous person or organization. Nobody knows. Their name was Satoshi Nakamoto. They created the Bitcoin network. What actually is Bitcoin network? People get very much confused between Bitcoin and Bitcoin network. About 90% of them think that both are same. But actually, Bitcoin is a cryptocurrency, and Bitcoin network is the network that manages the distribution of that cryptocurrency. Okay, so why you should learn blockchain? Let's put our philosophy aside for some time and get into the money perspective. Here is a survey report I have got from Google. It is freely available. You can see that. The demand growth for engineering roles. Front end engineer grew at 4%. The ML engineer, one of the most in demand technology, one of the most hyped technology in this today's world, the machine learning, intelligence engineers grew at 27%. Security engineers grew at 132%. Wow, more than double every year. But do you know at what rate blockchain engineers grew? 517%. Now just think about the supply and demand perspective. How much is the demand and how much is the supply? And as per the rules of simple economics, lower the supply, higher the price. Okay, so this is the average salary data. A normal software engineer of 0 to 1 years experience gets an average salary of $110,000 US dollars, whereas uh, 2 to 4 years experience get 124,000 US dollars. 4 to 6 years experience gets $143,000. But do you know, even a fresher blockchain developer can earn 143,000 US dollars, which a normal software engineer takes about 4 to 6 years. This is the this is the difference. This is the demand. This is blockchain. This is the power of blockchain. Why people are putting so much money in it? Why are tech giants investing so much? There must be a reason. So, how is actually blockchain going to change the world? Let me do a little bit zoom. Okay. Yes. Yeah. Okay. So, point number one, cannot be corrupted. Actually, blockchain is a network of widespread nodes which are there on every system connected to the blockchain, the chain. In order to modify the state of the blockchain, you need to follow the consensus protocol, according to which about at least 51% of all the nodes involved must agree what you propose. Second thing, the decentralized technology. The network is decentralized, meaning it doesn't have any governing authority or a single person looking after the framework. Instead, a group of nodes maintaining the network, making it decentralized. What does this actually mean? This means there is no Facebook controlling Facebook. I know that sounds a little bit absurd, but if in simpler words, the Facebook can't control what you put on Facebook. No one can tamper your content. No one can alter your content. The third being enhanced security. As it eliminates the need for central authority, no one can just simply change any characteristics of network for their benefits. Also, using encryption ensures another layer of security for the system. That's what I talked about. There is not one person controlling it. In order to change the state of the blockchain, in order to change what you posted, the person needs to change it on millions of computers individually. He needs to change it on millions of computers individually. Now just think of it, how many systems we are having in the world right now, and at what rate are we actually growing. The fourth point is distributed ledgers. Uh, if you are not familiar with the word ledger, let me give you a very short insight. A ledger is a document in which every transaction is stored in its order, in the specific order in which it is being executed. So, the ledger on the network is maintained by all other users on the system. This distributes the computational powers across the computers to ensure a better outcome. Again, the same thing. No single person is controlling anything. A change in state means it would be changed for everyone and on everyone's node. Fifth point, consensus. Now, the most promising thing, the most democratic thing. What is actually democracy? Majority? Decision of majority? That's what consensus protocol is. If you want to do anything on the blockchain, majority of the people must agree with you. And by majority, I mean at least 51% of the people must agree with you. Then only you can do it. Faster settlement. Faster settlement, it means blockchain offers a faster settlement compared to traditional banking systems. The way a user can transfer money is relatively faster. Okay, today if you want to transfer money to someone, what you do? You go to your bank server and you actually make a request to the bank that, hey, this money is in my account. Please take 10,000 from my account and transfer it to my friend. Okay, but it is your money. Should bank have any right to do anything with it? What if bank didn't transfer? What if we commonly say यार पैसा फंस गया. We do Paytm and we say paisa fas gaya. The money is stuck. Why? Because there is a middleman. There is a middleman involved. But in blockchain, there is no middleman involved. The network is peer to peer. If I want to transfer money to my friend, I will transfer it directly to my friend's crypto wallet or blockchain wallet. Nobody else needs to know. I don't need to tell bank manager that yes, I am transferring my friend this money. I have this money. Okay. So let's move to next slide. Let me zoom out. Yeah. So decentralized ledger. So, one thing I want you people to know. These two figures, Alice and Bob. Whenever you go to study blockchain on any site, on any portal, there is 90% chance that the example will be in the form of Alice and Bob. Uh, if the example is not in the form of Alice and Bob, it is the article is not worth reading. Yeah. So Alice and Bob. Suppose Alice wants to transfer Bob $10,000. Suppose. Okay. So Alice updates it. So as we talked, we are executing a ledger transactions. I transferred someone 1,000 rupees. Someone transferred me 100 rupees. How is this actually working? We have a proof, right? So Alice transferred Bob 1,000 rupees, $1,000. She put it on her ledger, and she broadcasted it to the blockchain network. Now everyone on the blockchain network can actually see what can actually know that Alice executed a transaction. They can't actually read the message, but they know that Alice executed a transaction, and the transaction was executed to this address. And there is not one system knowing it. As you can see, there are nodes. See, there are nodes. Okay, so if Alice didn't transfer Bob $1,000 and she mentioned it in her ledger, the transaction would get rejected automatically because the consensus protocol would not be fulfilled. This may sound a little bit overwhelming or intimidating right now, but believe me, in a few minutes, you would be getting a better insight of what's all going on right now. So, blockchain. Sorry for this hazy image. I guess if I zoom out a little bit, it's going to I did it too. Okay. So, how blockchain actually works? Blockchain is made up of two words: blocks and chains. So, whenever a blockchain is created, it is the first state of blockchain is called the genesis state, where the initial state of the blockchain is stored. It is like the blockchain is born at the genesis stage. So, suppose many people are executing transaction on blockchain all over the world. They send it to the blockchain network. There are a variety of blockchain networks right now. They send it to the blockchain network. The transactions, those transactions are then stored in a block. What does this block store? This block stores the record of transactions. But you may say that some time ago I said that no one can read my transactions, no one can do anything. So these transactions are stored in the form of hash, the hash code. And these in the next slide I will actually explain to you what is hash code. But these transactions are stored actually in the form of hash, and this hash depends on the hash of the previous block. So here is the twist. If I try to change the state of this block, okay, it will change the state of every block that it follows. Okay, every block that follows it, their state is going to change. So if I change the state of block 1, the state of block 2 is going to change. Since the state of block 2 is going to change, the state of block 3 is going to change, and so on and so on and so on. So as a result, what would happen? The As a result, what would happen? The consensus protocol would be broken. So what hackers do right now is that they go and they secretly modify the database of any company, right? Okay, but here if anybody tries to modify it, it is going to affect it is going to affect every other transaction that is present in the same block. So, and not every company is going to agree on that. So there won't be majority of people who would be agreeing on the transaction being executed, and hence it would be discarded. So until and unless I set up a thermal power plant in my backyard and I gain the computational energy equal to 50% of the total node miners in the world, and I do it for all the rest of my life, I make it my end goal that yeah, I committed a fraud 5 years ago, and if I don't keep doing those computational if I don't keep solving those computational puzzles on and on and on and on, I would be caught. Ultimately I would be caught, because if I am going to do computational work to change the state of this block, I have to do it for rest of my life, to make people believe that yes, this is the right hash, this is the right hash. If I couldn't do it, all someone else from the mining, there are thousands of miners all around the world, all of them are going to propose a chain that is different from mine, and 99% of them would be having a similar chain, but I won't be having a single percentage of similarity with their chain. What would that mean? That yes, I have committed the fraud, and there is nothing to do about the fraud. The world will simply reject my blockchain. The world will simply reject my blockchain. All the computational work I did whole my life would be actually wasted. So how is this hash generated? So there is a protocol, it is named as SHA-256. So you can see the mechanism by which SHA-256 gets generated. If I send a message to Dinky, hello Dinky, and if I uh, replace E with O, whole of the hash is going to change completely. It is not that if I change the single letter, if I change the single character, only some part of hash is going to change. No, it is not like that. Whole of the hash is going to change, and it is virtually impossible to reverse engineer this mechanism. The output, it is very easy to put in the input and get the output, but it is virtually impossible. It is virtually impossible until and unless you have a mammoth until and unless you have a mammoth computational power to run it. Okay, that's why it is so secure. Nobody can decrypt your nobody can actually decrypt your messages. Okay. So when blockchain was actually introduced in 2009 by Satoshi Nakamoto, uh, he introduced Bitcoin that only supported financial transactions. It can't do anything else. So around after some time, there a group of individuals used to publish a magazine called the Bitcoin magazine, and one of them was Vitalik Buterin. So he actually recognized the power of blockchain and decided to harness it for various other uses. And that's how Ethereum blockchain network was born. Ethereum is not a cryptocurrency. The native crypto for Ethereum is called Ether, symbolized as ETH, capitals ETH. The native cryptocurrency for Ethereum is Ether. Ethereum is not any cryptocurrency. Okay. So how Ethereum actually works? So here is a case study. We have two scenarios. One before the smart contract. By the way, smart contracts, I will get into it very soon, and we will write a smart contract too. So before blockchain was actually implemented, suppose if you want to buy a house, if Alice wants to buy a house from Bob, again, same Alice and Bob example, what she would do, she would get to a lawyer, she would get to a broker, she would have to get an insurance. So there are a lot of middlemen involved right now. You can see you have to get an affidavit from the court. You have to ask your boss for leave, like, I have to go to court to get my house registered and all. And at last, after doing all this computational hard work, you are going to get the title of your house. You are going to get the ownership of your house. But now, what is actually going to happen? Suppose Alice wants to get a house. Okay, Alice gets to know that, yeah, Bob is selling a house. Bob is selling his house to Alice. Is the business between Alice and Bob. Nobody else should care to know how they are doing it and why they are doing it. So there should not be any lawyer, any broker, or any insurance agent between them. What they would actually do it, Alice will prepare a ledger and Bob will prepare a ledger. Okay? Alice will say that I am transferring $10,000 to Bob in exchange for the property rights of his house. Okay? What Bob will write in his ledger is I am writing the property rights of my house to Alice in exchange of $10,000. And both of them will forward it to the blockchain network. Right? Now there is a condition. If Alice transfers Bob $10,000, then only Bob should transfer the property rights to Alice. Earlier, this work was being done by lawyers, brokers, insurance agents, court, judges, police. Everyone was involved. But now, as soon as Alice transfers Bob $10,000, the property right of Bob's house is in the hands of Alice without any delay, without the delay of a single second. If I want to buy a house, I can buy it in 10 seconds using crypto. I don't need to involve anybody else in it. I don't need a court. I don't need someone specially assigned from the government to actually put up a stamp on it that yes, this house now belongs to this person and this person has transferred this, and pay and actually pay the processing fee at the court, or extra money is being expenditured at lawyers and brokers. No, I don't need to pay any commission. I can transfer directly to this seller, Bob, and as soon as I transfer, the transaction gets confirmed on the blockchain. 51% of at least 51% of the people on blockchain agree that yes, this person has transferred Bob $10,000. It's now in the record. It's now in the ledger. Please assign the property rights of Bob's house to Alice. That's so simple. That's how simple it is. Get great. So now I'm going to touch a very hot topic of nowadays, that is NFTs. Okay, you must have seen a lot of ads on Twitter, YouTube, that man became a millionaire overnight by selling NFTs. The picture of a monkey is being sold for $1 million. Like tweet is being sold for not being sold, they are being actually auctioned. People are people are bidding for them, is for millions and millions of dollars. But why do they do it, and what actually NFT means? NFT stands for non fungible token. Now the two words are there, non and fungible. What does actually fungible means? So I would give a very simple example. Suppose I have a 100 rupee note and my friend has a 100 rupee note. If me and he exchange our notes, there is no effect on the value of that note. There is no effect. Both are still same. I have a 100 rupee note. Mukesh Ambani has a 100 rupee note. My 100 rupee note has same value as the 100 rupee note of Mukesh Ambani. But what if I talk about your favorite car, the first car of your family? What about it? In how much are you going to sell it? See, if anybody other than you gets your car to sell, he will sell it in the highest possible market value. But what you would do, you are not going to count the prices of the components being used in your car. What is the state of your engine? What is the state of your carburetor? You are not going to look at it. You have memories with your car. You have your emotions attached with your car, and that is non fungible. That cannot be exchanged. Your 100 rupee note can be exchanged, but your memories, your personal things cannot be exchanged. And that is what is being leveraged through the non fungible tokens. The piece of arts, the monkeys, the apes, the board ape collection which you saw on the OpenSea, the leading NFT marketplace. The board ape collection which you see on OpenSea, that is considered as a piece of art and a rare piece of art. Frankly speaking, I don't have such a good taste of art, but if someone is buying it for $1 million, it must be having something within it. Okay, so people are actually buying it as a piece of art. Now they own that art, and they own that art is digitally imprinted. Now nobody can steal it from them. It is not like a purchase the $100,000 painting, and one night a burglar came into my house and he stole it. That is not going to happen. That art has been registered, has been transferred. The rights of that art has been transferred to the buyer. Now the maker holds zero interest. The maker holds zero rights in it. And we talked all about this, no? The decentralized banking system, blockchain, hash codes, SHA 256. But how is it actually implemented? Like, we cannot cook it in our kitchen. There must be a way to write programs and all, because all of this is being introduced on implemented on internet. There must be some programming thing involved. So let's get into that. Okay, so let me introduce you to Solidity. I'm sure many of you have heard this word for the very first time. Solidity is a very new language, very new, just born, just 10 to 12 years. A very new language and a very powerful language. It is a high level, statically typed programming language. What does high level mean? High level mean that it can be that it the programs can be written in a way that even humans can understand, like simple English, the way we write in C, C++, Python, JavaScript. We don't use binary notations for that. We write in simple English, statically typed. Now, what does this statically typed means? If you have ever programmed in JavaScript or Python, you actually see that you don't need to specify the type of your variable. Just say let x is equal to 10, or let x is equal to xyz, let x is equal to 0 point something something something. You don't need to specify the type of your variable. But in Solidity, you actually need to specify of what type of variable are you actually creating. Is it an integer? Is it a string? Is it a boolean? Is it a struct? Okay. With Solidity, you can create smart contracts for various uses, such as voting, crowdfunding, blind auctions, as well as multi-signature wallet. Now, there comes a one more implementation of blockchain voting. Nobody should know to which party are you actually voting, isn't it? Why should anybody know? Crowdfunding, blind auctions mean nobody should know who bought what. Yeah. Multi-signature wallet, I'm not getting into wallet because that is a very deep topic in itself. So yeah, let's go and write our first ever smart contract. Okay. So right now I would be going to my browser window and I would be typing remix. Okay. The first result, remix, Ethereum IDE. We are working on Ethereum virtual network. It is an online IDE. It is actually like an online IDE for creating and deploying smart contracts. It is a very good place to start with. Uh, if you actually want to get started with, uh, let me create a new workspace. What the heck? Okay. Okay. So we are now on what the heck. Dinky, can you please confirm if my screen is visible?
Yes, it is visible.
Okay, so thank you. So this is Ethereum IDE remix. You can see it has a very very different structure. A very cute, I don't know what it is, a dinosaur or something playing guitar for us. Yeah, few folders already for us by Ethereum. We are not going into them. We are actually going to see how we can create smart contracts. So in contracts, I'm going to create a new contract. You can use this symbol, create new file, to create your contract, and I will name it. Uh, what should I name it? Yeah, mood, mood, mood. Okay. Solidity files are saved with the extension .sol, .sol. So .sol. Enter. So here we are in the Solidity IDE. So the very first thing, as I already mentioned many times, the uh, the blockchain, about most of the blockchain is open source. Most of the applications being built on blockchain are open source. Okay. So the on the very first line of our block of our smart contract, we actually need to specify how are we going to use this smart contract. Is it open source? It is commercially licensed or whatever. So what we do on the first line is we write SPDX license identifier MIT. What does this mean? I am licensing this contract with the MIT license. MIT license is a sort of open source licensing. So my contract, the contract which I am going to create, is open source. Okay. So what again we do is we write pragma, solidity, and version. Yeah, version 0.8.0. Let's say semicolon. What this line means is, for my smart contract, for smart contract which I am writing, use the Solidity version 0.8.0 to compile. Don't use any other version of Solidity to compile, because my Solidity program may have certain functions which are supported only by the compiler version 0.8.0. Okay, simple stuff. Now, after that, we write contract, the name of our contract. Although these are called smart contracts, but believe me, neither they are smart nor they are contract. I don't know why they named it smart contract. We actually have to program it. Mood. It is the good development practice to specify your contract name with uh, capitals. Start your contract name with capitals. Okay. So here we are. Now, what we are going to do? We are going to create a simple string mood. Okay. Now, let's understand the syntax of function. First, let me write it. Function get mood mm, function get mood. Just let me once check what. Okay, yeah. So function get mood view returns returns string memory. Okay, so we are going to return our mood. Let's initialize mood with let's say I am very happy right now. Yeah, I am actually very happy right now. Okay, we will be returning mood. So let's understand this syntax. No, let me write the set mood function too. Function set mood. What it would be taking as an input is a string memory new mood and it is going to return. It is not going to actually return us anything, so let's leave it here only. Okay, so yeah, so now what it would do is would do mood is equal to underscore new mood. Great, awesome. So let's understand the syntax of function syntax of Solidity. Here we specified. Here we actually initialize declared as well as initialized a variable of type string whose name is mood and the value is assigned to happy. Okay. Now function get mood function, the keyword function, the name of our function, parentheses view. What does this view actually means? So let me tell you that in order to uh, in order to view something from the blockchain, we don't actually need to pay any convenience fee. Okay, we don't actually need to pay any gas fee. Gas fee is a very vast topic in itself, that is out of scope of this session. View means we are not changing the state of blockchain, we are just viewing blockchain returns. This means that this function returns a string which should be stored in the memory. Again, memory keyword means if you are familiar with heap and stack, the memory keyword would store your returned item in stack, not in the heap, because storing in heap would mean it to store it on blockchain, so it would be costly. Yeah, and we will be returning mood, our variable. This has global scope. Now new function set mood. Now we are actually passing a argument. Okay, we are actually passing an argument. No, it is not an argument. It is a parameter. Okay, it is called a parameter. We are actually passing a parameter string type memory, means store this input in the stack of the program, new mood. the name of the variable, and then set mood to new mood. Okay, so now let's compile it. So we can compile it from here. The third icon, from the left pane, compile. Okay, what warning it is giving to us? Okay, I did one. So it's not an error, it's a warning. Capital I. Okay. Oh no, just leave it as it is. Hmm. SPDX license uh, identifier. Okay. Okay. Good. We are good to go. Okay. What error are we having here? Okay. 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 Now we have to make it public actually. We have to specify the visibility of the uh, functions and means whatever variables we are creating. We have to actually specify the visibility. So public means anybody can access. Private means nobody can access until and unless the creator wants. Here also I will say public. Okay, I guess now we are good to go. Hmm, what is now here? Hmm. Oh, sorry. I need to put it here. Okay. Yes. Okay. Let's have a live debugging session. On line 5, contract public. Okay. Control V. Hmm. What error are we having here? Contract public mode. Okay. What error are we having here? Let's just uh, go and check. Mm, yes, contracts, my contract. Mm, what error are we having here? Okay, okay, that's cool. What the heck? Contracts, move.solve. Mm, public view returns. Hmm. Let's try to compile again. Oh, 1 second. 0.8. Hmm. Okay. Go again. No, not here. That's all. String. Um, public view chance. Okay. Got it. Okay. So we have a similar program here. Uh, I just copied it to a different workspace. I was getting some error in that. I don't know why, but online IDs sometimes are a headache. Okay. So we would try to compile it here. It is being compiled. Yeah, it has been compiled successfully. I don't know why my workspace was giving me headache. Okay, so now let's deploy it. Let's deploy our contract. Okay, so here you can see our environment. Select JavaScript virtual machines since it is your first smart contract, gas, leave these things as it is, and click deploy. Success, success here. This is our contract. Okay. Hmm. So first, what actually, what Solidity does actually is, it provides you a UI, a user interface, to actually view or change your you view or change your smart contract. Not view or change your smart contract, but to interact with your smart contract, Solidity provides us with a user interface. So here I made a get mode function and I set it to public. I am getting user interface. If I click on get mode, I will get my mood. Okay. If I click on set mode, I will get to set my mood. So if I click on get mood called string, since there is no mood set right now, let's set our mood to happy. Set mood, success, get mood, happy. Happy, happy everyone. So that's all was from my side. I guess we are running out of time too. So blockchain, apart from just being a technology, it's a very wide concept, and I think you must get deeper into it, because money is not the motivation, but the technology involved in it is. Yeah, yeah. So thank you.
So, thank you so much, Shaurya, for such an insightful session. And I think viewers would have enjoyed it a lot. And literally, blockchain is, a revolution in itself. And so we have a question over here, like who support blockchain to run economically?
Actually, as I said, blockchain is not supported by anyone, neither blockchain is opposed by anyone. The how
Mhm.
blockchain actually works is a very different concept. What happens actually is, in order to change the state of the blockchain, you have to solve a computationally hard puzzle, which requires a lot of resources. Like you have to set up a very different kind of system in your home, like various GPUs, CPUs, and that is computationally very hard. So whenever a miner, the person who is setting up the block, means who is trying to change the blockchain state, okay, when he succeeds in solving that computational puzzle, since he he actually uh, ac- he actually spent from his own pocket for all the work he did, he gets an incentive in the form of native currency of that blockchain. In Ethereum, that is 2 ether per block. Suppose if I succeeded in adding one block to the Ethereum blockchain, I would get 2 ethers as incentive. Everybody is putting their
Okay.
own, means, yeah, it is supported by everyone. Peer to peer network. That's what it actually means.
Okay, thank you so much then. I guess that's all
Yeah.
for this session. And it was a great session as and we'll see you in our like finals then. Thank you everyone for
Yeah.
joining in
Thank
for
you.
tonight.
Thank you. Thank you
Good
everyone. Yeah. Thank you.